Good morning, guys. This is Genius Guide tutorial. I'll be teaching you guys today on how to know if a vector span R cube or R square. Now, how this example? This example says that state if the vector 1 0 minus 1 minus 1 1 0 and 0 1 minus 1 span R cube or R square. Now, solution to solve this: bring down the vector. Here is 1 0 minus 1 1 0 minus 1. Here is minus 1 1 0 minus 1 1 0. Here is 0 1 minus 1. So here is 0 1 minus 1. Now, after doing that, identify identify the diagonal of this matrix, and the diagonal of this matrix is this. So it mean that once you identify the diagonal of the matrix, any number below the diagonal, you make it to a zero. So means I have to make this zero, and this zero. And if you check this is already this number is already in zeros, and this one is already in zero. So it means I have to make this zero, and to make this zero is what? Look at what I did. Row 3 plus what? Row 1. So that is row 3. This is row 3 and this is row 1. So row 3 plus row 1 will give you what? So that becomes, you bring this down, 1 minus 1 0, 0 1 1 0 1 1. So we mean that now to make this 0 become this plus this will give it a 0, and this plus this will give you minus 1, and also this plus this will give you what? Minus 1. Now after doing that, if you check, I have to make, since I have to make this 0, this 0, and this 0, and if you check this number has become 1, so I have to make it 0. So to make it 0 is what? You could look at what I did: row 3 plus row 2. So this is row 3 and this is row 2. So row 3 plus row 2 will give you what? That is, bring down this number: 1 1 minus 1 0 1 minus 1 0 0 1 1. So therefore, to make this 0 become what? Row 3 plus row 2, that is 0 plus 0 will give you 0. This plus this will give what? 0, and minus 1 plus 1 will give what? 0. Now after doing that, you do what? You identify the diagonal of the matrix, and the diagonal of this matrix is what? Is 1 1 0. And also know that to know if a vector span R cube, the diagonal of the matrix must not contain any 0. So if you take this, the diagonal of this matrix contain 0. So that means that this matrix is not span to what? R cube. So look at our statement. This says that since their eigenvalues are not linearly independent, so the eigenvalues, these are the eigenvalues, that is the diagonals are the eigenvalues, and also since their diagonals contain a 0, now therefore the vector is not span to what? R cube. So that is it. Now I have example 2. Example 2 state that state if the vector 2 1 1 minus 1 span R cube or R square. Now solution: to make this, you bring this vector 2 1 1 2 2 1 and 1 minus 1. Therefore you have to identify your diagonal matrix. and your diagonal matrix here is 2 and minus 1. So any number below the diagonal becomes what? 0. So the number here is what? So I have to make 1 0. To make 1 0 is what? That is 2. That is what? 2 row 2 minus what? Row 1. So this is row 2 and this is row 1. So 2 row 2 minus row 1 will give you what? 2 times 2. Bring this down, 2 and 1. Now 2 times row 2, 2 times 1 is 2, minus row 1, that is 2 minus 2 give us 0. Again here, 2 times minus 1 is minus 2, minus row 1. So minus 2 minus 1 will give you what? Minus 3. Now therefore, if you check this, now what is the diagonal? The diagonal of this matrix has no 0. Now since it has no 0, therefore yes, the vector span R square. Do you know why is arrow square? Is arrow square because there are two vectors here. How many rows are here? 1 2. And how many columns are here? 1 2. So it means that this vector is what? Arrow square. If you check this one, this vector is arrow cube, since it has what? 3 rows and 3 what? Columns. Okay. Now therefore this is the word. So you say yes, the vector span arrow square, since they are eigenvalues. These are the eigenvalues. That is the diagonal. Since the eigenvalues are linearly independent, and also the diagonals has no 0. If you check it, the diagonal has no 0. So it means that this vector span what? Arrow square. Okay, guys. I have another question. Another question say that, example 3 state that state if the vectors, if you say the vector 130, 1 minus 2 minus 1, 2 1 1 span r cube or r square. Now solution, I have to bring this vector down. 130, 1 minus 2, we have 1 minus 2 minus 1, and then we have what, 2 1 1. Then now therefore I have to identify the diagonal matrix, and the diagonal matrix here is this. So any number below this is become what? I have to make it 0. So I have to make this 0, this 0, and this 0. So therefore to make this 0 now, what do I do? Row 2 minus what? 3 row 1. Okay, that's row 2 minus 3 row 1. So I bring it down 1 1 2. Now I have to make this 0, right? So that is row 2 minus 3 row 1. Row 2 minus 3 row 1, that 3 times 1, 3. 3 minus 3 is 0. Now minus 2 minus 3 times 1 is 3, that will give you minus 5. And here is what? 1 minus 3 times 2 give you, that will give you what? 1 minus 6 will give you what? Minus 5. Now you bring down 0, minus 1, and 1. Now after that I have to make this 0. So to make this 0 become what? 5 row 3 minus row 2. That is 5 row 3 minus row 2. It become what? 5 row 3 minus row 2. So I have to bring it down 1 1 2 1 1 2. So 0 minus 5 minus 5, 0 minus 5 minus 5. So if you check this now, that becomes 5 row 3 minus row 2, right? So 5 row 3, this is row 3, and this is row 2. 5 row 3, that is 5 times 0, 0. 0 minus 0 is 0. 5 times minus 5 is minus 5. Minus 5 minus minus 5 will give you what? 0 again. And 5 times 1, 5 times 1 is 5. Minus 5 will give you what? 10. So then that is minus is plus. So therefore, let's identify the diagonal of this matrix, and the diagonal of this matrix is what? 1 minus 5 and 10. So therefore, if you check in this diagonal of the matrix, it has no zeros. So it means that yes, the vector span R cube. Since the eigenvalues, these are the eigenvalues. Since the eigenvalues are linearly independent, and also the diagonals contain no zeros, so it means that the vector span R cube. Please guys, if you find this video interesting and helpful, please do like and subscribe, and also share. Thank you.